In this video, we're going to be talking about the other common type of loop, which is the for loop. We're going to go back and take a look at our guessing game program to see why we might want to use a for loop instead of a while loop. Now, in our previous version, we allowed the user to keep guessing until they got the right answer, which means theoretically they could always get the right answer if they guessed long enough. We have values between 1 and 10, so all they have to do is guess every number between 1 and 10, and we'll eventually tell them, yay, you got it right. Instead, what we could do is we could give them a set number of guesses. And that way they only have, say, 3 tries in order to get it right. And a good way to do this is with a for loop. So let's look at the syntax. The for loop is a little bit more complicated than the while loop. It has 3 pieces to it. The first is the initialization statement. That happens at the beginning of the for loop, but it only happens once. So one time at the beginning. Then there's a conditional expression. Similar to if statements and while loops, if the conditional expression is true, then we will run the statement that is inside the for loop. Then we're going to run the increment statement. So for loops are commonly called counting loops because usually they start at some initial value and increment upwards until some conditional expression is met. So let's look at an example. Like most of our other constructs, we can use these curly brackets to include more than one statement inside the for loop, and that's pretty common. But you can also see for loops without it. So here's our example. First, we run the initialization statement. We're going to take this variable counter, and we'll assume it's already been declared, and set it to 0. So that's our initialization. It only happens once at the very beginning of the for loop. Then we'll check the conditional expression. If, in this case, if counter is less than or equal to 10, then we'll run the contents or the body of the for loop. Now 0 is less than or equal to 10, so we are going to print the value of counter. Then, after we've completed the body of the for loop, we'll do the increment statement. Now this one says counter plus plus, so we're going to take counter and increment it by 1. So now counter is 1. Then we'll check the conditional expression again. And if 1 is less than or equal to 10, then we'll print the value of counter and increment it again. So now counter is 2. And if 2 is less than or equal to 10, we'll print the value of counter and increment counter. And we'll increment counter to 3. So we're going to continue doing this until our conditional expression is no longer true. So let's fast forward to, say, counter equal to 10. 10 is less than or equal to 10 because 10 is equal to 10. So we're going to print the value of counter. Counter equals 10. Then we're going to increment counter. So now counter is 11. We're going to check to see if 11 is less than or equal to 10. And since it's not, we'll exit the for loop. But counter retains the value of 11 throughout the rest of the program unless we change it with another assignment statement. So let's take our example over to CodeBlocks and see what it looks like if we run it. We're going to put this little snippet inside of our blank test program again just because it's not something we need to hold on to for a long period of time. We just want to take a look and see what it looks like. So here's all of the values of counter, all of the iterations of our for loop. So every time we go through the loop, it's called an iteration. Start counter at 0, as long as it's less than or equal to 10, print out the value of counter, increment counter by 1. So we see all of the values that are less than or equal to 10, starting at 0. But remember what I said about counter. Counter remains at its current value even after the loop has completed. So this is after the loop. Counter should have the value 11 because that's the value counter had that caused the loop to stop running. And there's the proof by IDE, all the values of counter that are less than or equal to 10, and after the loop, We've not changed counter any, we just printed it out. Counter has the value 11. So now we can use this to modify our guessing game a second time. I'm going to take the original here and save a new version. This is guessing game with for loop. We'll keep a couple of things the same. We need to determine how many guesses we're going to allow the user to have. That'll be the max number of guesses. We're going to start it at 3. We also need to track the number of guesses that they've currently used. The max is 3. But which guess are they on? Are they guess on 1, 2, or 3? We'll keep this part the same. We need to seed the random number generator and get a value. We're going to modify the rest of this. So we'll build our for loop to use num guesses, and we need that value to be less than max in order for them to keep playing the game. We can choose to start at 0 or 1, and that will affect how we set up our conditional expression. If we start at 0, then we need to go until we're at strictly less than max. And each time they guess, their number of guesses goes up by 1. Now if we were to start num guesses at 1 instead, then we would want to go less than or equal to max. And either of those is fine, but starting at 0 is very common, and that will make more sense when we talk about arrays. But in computers, we start counting at 0. So we're going to prompt the user to guess. We're going to scan in their guess, store that in guess, and then we need to take care of something in particular. If they guess it right, we shouldn't keep asking, because what if they guess it right on the first guess? Then we don't want to ask them for guess 2 and 3 because they already know the answer. So if they got it right, we're going to go ahead and say, you guessed the secret number, good job. And we're going to break out of the for loop. So break is a keyword that we introduced in our switch statements, and it did the same thing there. It broke us out of the switch statement. So you can also use it in loops as a quick exit for the loop. This is don't increment guess anymore, don't check this, just leave the for loop, break out of it. If we were going to print out a final statement that says if they didn't get the answer right, we need to know whether or not this was ever triggered. So we're going to add in a flag. Now flags can start at any particular value and switch to any particular value when a particular event is triggered. 0s and 1s are most common because that's our representation of Boolean values. I've started flag at 0 because 0 represents false, and that's going to kind of stand for they've never guessed the secret number. And when they have guessed the secret number, we're going to change flag to 1. So now flag represents they did guess the secret number. So if they never guessed it, we'll have a final message at the end that says what the secret number was. Sorry, you ran out of guesses. Now we'll check it to make sure that it's running the way we think it should. We've got one more part to fill in, and that's this value right here. We said guess number blank, and that's so that they'll know which guess they're on. So that's controlled by the number of guesses. And then we want to print out one higher than that number. So we're going to count 0, 1, and 2 for the number of guesses. But we want to print out 1, 2, and 3. So we're going to print out a value that is 1 higher than NumGuess's current value. Let's check it out. Okay, so we're on guess number 1, 1 of 3. We need to guess the secret number. We actually want to guess it wrong so that we can see the final printout. And then we want to do another version where we do get the right number. Okay, so in this case, we ran all 3 guesses. We ran out of guesses, and the secret number was actually 10. So let's try again. So in this version, we guessed it right on our 3rd guess, and it says you guessed the secret number. And then it does not print out any of these final statements down here because we tripped the flag so that it doesn't print this out. We did not run out of guesses. We guessed it right on the 3rd one, and everything's working the way that we think it should. So now it's your turn. Write a short program that takes an integer from the user and then uses a for loop to print a symbol of your choice. I've used an asterisk, but you can use whatever you want. Print that many symbols. So if they give you 5, print 5 symbols. If they give you 7, print 7 symbols, so on and so forth. And in our next video, we'll talk about what happens when we mix all of our constructs together. We'll put if statements inside for loops and while loops inside if statements, and it'll be a lot of fun. I'll see you then.